So we performed a hypothesis test on the slope. We can also find a confidence interval for the regression slope beta 1. So that confidence interval has the form beta 1 hat, the point estimate, plus or minus T alpha over 2 times the standard deviation of the sampling distribution of beta 1 hat, which we approximate by S over square root of SSXX. And T alpha over 2 is based on n minus 2 degrees of freedom. So for our example, we want to construct a 99% confidence interval for the slope beta 1. So alpha then is 0.01. Our degrees of freedom will be 4 minus 2, which is 2. 99%, so alpha over 2 is 0.005. And we can compute that using the 005 is the right area, so the left area is going to be 0.995. And then degrees of freedom will be 2. Put that into inverse t. So second variables, inverse t number 4, 0.995 left area, degrees of freedom 2, 9.925. And then recall that our beta 1 hat is negative 0.00861. S, the most accurate value, 0.84853. So that was from the TI calculator. Remember, the value that we calculated by hand was off in the fourth and fifth decimal place. Sum of squares of XX was 287,500. So here's our interval. So beta 1 hat out in front, negative 0.00861. Plus or minus 9.925. And then S is 0.84853. And we are dividing that by square root of 287,500. So let's go ahead and compute this margin of error. So negative 0.00861 plus or minus. So that margin of error will be 9.925 times our 0.84853 divided by square root of the 287,500. So 0.1571. So we will add and subtract the 0.1571. So negative 0.00861 minus 0.01571. So on the low end, 0.2432. And then we add it on the high end. .0071. And remember that means our conclusion here is that we are 99% confident that the true slope of the regression beta 1 is between negative 0.02432 and 0.0071. And remember, that means that if we did repeated samples, if we did 100 samples, that 99 of those 100 samples would contain the true slope beta 1. So with repeated samples, %, would contain 99% of the intervals. 99% of the confidence intervals, CIs, contain beta 1. And then we can do this on the calculator too, using stat tests and then lin/reg t interval is the function there. So if we go to the calculator here, stat, we already have our data entered in, tests, and then it's way down at the bottom. So if you go up, you see t interval, lin/reg t interval, enter. List 1, list 2 for x and y. C level is our confidence level, 0.99, and calculate. And there's our negative 0.0243 to positive 0.0071. And it also lists our S here, and then B and A, and then R and R squared. Take a look at the sample Jamovi output here. So if you look at the model coefficients and check off 99% confidence interval, then we've got our intercept and dose, and then they give lower upper for both of them. So dose is our slope here. So this is slope. And we can see our 99% confidence interval right there agrees with what we did by hand. So just by way of review, this is our intercept, this is our slope, so the regression line, y hat, is going to be beta 0, 8.47826, minus 0.00861 times x, so that's beta 0 hat, beta 1 hat, and then the 99% confidence interval for the slope, negative 0.0243 to 0.00712. So that's how you read that output.